This video is going over the front page on the third worksheet for this unit. This is actually our final worksheet before the review, and then the final assessment, a small quiz. So this front page should have been pretty straightforward. This is what you guys were asked to do, and then we will go over one example from the second page, which is calculations. So you guys were supposed to do the vocab and the true and false section on the front, so we'll go over that and then do an example. So 1, variables that affect the strength of gravity, that should be d, mass, and distance. 2, variable that inversely increase means you decrease the force of gravity. So if we increase the distance, you decrease the force of gravity. So C for number 2. 3, variable that directly, if you increase that variable, that you increase the force of gravity, that is mass. You increase mass, you increase the force of gravity. Number 4, an attractive force between any two objects, that is the force of gravity, A. 5, acceleration due to gravity, or in this case it has to be on Earth, so that'd be E, 9.8 meters per second squared, or little g, so E and G for number 5. 6, gravitational constant used to calculate the force of gravity, that should be H and F. Big G, that's our gravitational constant, or 6.67 times 10 to the negative 11th newtons times meters squared divided by kilograms squared. That is our gravitational constant. And then 7, the formula for Newton's law of universal gravitation, the only formula we've gone through so far in this class, in this unit. That is that the force of gravity is equal to the gravitational constant times mass 1 times mass 2 divided by our distance squared. So that should be the vocab section up here. If I went through that too quickly, please rewatch the video and maybe pause it every once in a while. 8, circle the best word from the choices. There would be a stronger gravitational force between two large objects that are close to each other. Large objects close to each other would have more gravity than small objects that are far away. 9, which of the following are true statements about the gravitational force? Circle the letter of the true statement. So you're just telling me, okay, if A is true, you just circle it or underline it or highlight it, whatever you can do on your computer. A, the gravitational force only acts between very, very massive objects. That is false. B, gravitational force between an object and the Earth is inversely related to the distance between the objects and the Earth's center. That is true. Gravity will go down as distance increases, as distance goes up. Gravitational force or weight can be accurately calculated by multiplying the object mass by the acceleration due to gravity. That is true. That is Newton's second law. Mass times acceleration equals force. In this case, the force is gravity, so we take the acceleration due to gravity. D, the gravitational force acting upon an object is the same as the weight of the object. That is true. E, the gravitational force between two objects depends on the mass of both objects. That is true. F, if object A gravitationally attracts object B with a force of x newtons, then object B will also gravitationally attract object A with the same force of x newtons. That is true. It's kind of weird to think about the fact that you and the Earth pull each other the same amount. The reason that you actually end up moving is because you are less massive, so the same amount of force will have a greater impact on you. The Earth being way more massive, it won't actually move because of your pull. G, the doubling of the separation distance, 2d, measured from the center, between two objects will have the gravitational force between the objects. That is false. It would go down by a fourth in that case. H, if an object is orbiting the Earth, then the force of gravitational attraction between the object and the Earth will be less than the magnitude on the Earth's surface. That is true, because the further you get, you're increasing the distance here, so you're decreasing that force of gravity. And then I, orbiting astronauts do not experience a force of gravity. This explains why they feel weightless. That is false, otherwise they would fly off into space. Right? They experience a little bit of gravity still, but then they are not being affected by it because there's another force that counteracts that. Right? 10. The more massive an object is, the more that the object will be attracted to the Earth. The more massive the Earth is, the more that another object will be attracted to it. And then number 12, the greater that the Earth's radius is, the less that another object will be attracted to the Earth. Really, you're increasing the distance for number 12. So I'm going to skip down here, give you a little bit of a hint for 16. For 16, please know that this is a very, very small person and another very, very small person very close to each other. Please think about, are they going to have a very large amount of gravity or a very small amount of gravity? I think in the past kids have kind of freaked out, like, I don't think I got this answer right, but please think about it. Are these two large objects? Right. So for number 17, determine the force of gravity of a 60 kilogram student on Earth, which has a mass of 5.98 times 10 to the 24th kilograms and a radius of 6.37. So there's my distance, there's mass 1, here's mass 2. So the only thing else I'm going to need is my gravitational constant. Right? So I'm going to plug all of this stuff into Web 2.0 Calc because that is going to make this a lot easier. So 6.67 e to the negative 11th times, let's see, what was the mass? It was a 60 kilogram student. Let's just double check. 6.67 times 10 to the negative 11th. Okay. Times 60 times the mass of the Earth is 5.98 times 10 to the 24th. 5.98 10 to the 24th. I'm going to put all of this in parentheses because that's what's on top. And then I'm going to divide that. I'm going to divide all of that by my distance. Okay. But there's something else that I should be thinking, right? It's not just divided by the distance, it's divided by the distance squared, right? So please make sure that you guys remember to always square the distance. So in this case, the radius is 6.37 times 10 to the 6th. 6.37 times 10 to the 6th. Now if I just plug that in, this is going to give me the wrong answer. Right? I need to make sure I square it, and this is why I like Web 2.0 Calc, because then you can come back here and edit it and make sure that you are doing this correctly. Right? So 6.37 times 10 to the 6th, square that, divide by my gravitational constant, and my mass 1, and my mass 2. So plug that in, and you should get 589.7, right? So that is the force of gravity between the 60 kilogram person and the Earth. Now some of you are probably thinking that there might have been a really much easier way to do this, right? I got 589, or 590 if you round up, and that seems like a lot of work. But let's go back. If I had asked you earlier, even before this unit, to find the force of gravity acting on a 60 kilogram person, a lot of you would have been able to do that, right? All you need to do is just, okay, it's a person on Earth, so 60 kilograms times 10, and we get their force gravity around 600. Right? So why is it that this number is different? Why is it 600 and the other one is 590? So this is one of the cases where it's actually a little bit more accurate to do 9.8. Right? And if we do 9.8, we end up with pretty much the exact same answer that we had earlier. When I used the larger gravitational constant, Newton's law of universal gravitation, right? So if it's on Earth, you can do this as a way to double check your answer. Okay, you know, whatever the mass is, if the mass is 70 times 9.8, and that should tell you whether your answer is close or not. The answer I showed you guys earlier, or the question I showed you earlier, number 16, that's not going to help you. Multiplying your 52 by 9.8 isn't going to help you because this isn't talking about the gravity between the mother and the Earth. This is between the mother and a child, right? So you can't multiply it by 9.8. So in this case, the only way, for number 16, the only way to solve that one is to use our formula up here. But using 9.8 times the mass is a helpful way to double check your answer if it's on Earth. Number 18, again, that's not going to help us because it's on Pluto, right? So anyway, please work your way through 13, 14, 15, 16, 18, 19, 20, 21, 22. If you don't know what scientific notation is, please let me know, or you can look it up on your own as well. That's something that might be helpful for you because some of these numbers are really big and are in scientific notations. So please just finish this worksheet for the rest of the hour today, and have a good day. All right, bye.